So let's take a look here at how to find the number of neutrons in an atom. Now, before we get started on this, I'm just going to run through a couple sample problems, because usually when I teach this to students, they start to freak out a little bit, and I want to show them that it's quite simple and not be scared of the big words. So let's just say you had a bowl of fruit, and inside that bowl of fruit, you only had two types of fruit. You had a bowl of fruit that had 12 apples and oranges in it. So there's 12 pieces of fruit all together. There's some mix of apples and oranges, but there's just 12 pieces altogether. If I told you that the number of apples you had in that bowl was 6, and I asked you to figure out how many oranges there were, you would think this is quite simple. You'd say all we have to do is subtract those two, and we know that there's 6 oranges. All right, easy enough. Try another example just to build our confidence here. In a box, you got a bunch of skateboards and bikes for some reason. Don't worry about the logistics of it, but you got 54 skateboards and bikes mixed together in a box. In that box, 14 of them happen to be bikes. If you know that there's 54 total, how many skateboards would be in there? Once again, you're probably like, this isn't so hard. I like this. All you have to do is subtract that out, and you'd find out that you have 40 skateboards. All right, here's the example I want to talk about. Hopefully you are familiar with this. Imagine you got another box here of stuffed animals, and it's filled with puppies and narwhals. Okay, so in case you didn't know what a narwhal was, it's the unicorn of the sea. Looks like a whale, big old tusk on the front of its head. Let's imagine that you had 65 stuffed animals in that box, a mixture of puppies and narwhals, and you had figured out that there are 30 puppy stuffed animals. How many narwhals are in that box? Once again, not too hard. We just subtract the 2 and you get 35. And I know you're thinking, okay, what does this have to do with neutrons? Just go with me here. Try this example for you. Calculate the number of neutrons in an atom of zinc. All right, let's figure out the number of neutrons in an atom of zinc. Zinc has an atomic mass, or a mass number, of 65. All right, its atomic number is 30. How many neutrons does zinc have? And this is typically where students then go, well, let's just take a look at what that means. Atomic mass, we remember before, means it's the number of protons plus the number of neutrons. Okay? Atomic number, on the other hand, is simply just the number of protons. In this question, I had asked you to figure out the number of neutrons. So if you take a look at it this way, when I tell you the atomic mass, I'm telling you that there are 65 particles, subatomic particles in the nucleus, and it's a mixture of protons and neutrons. The atomic number tells you that 30 of those things happen to be protons. So how many would have to be neutrons? All you have to do is subtract the 2. 65 minus 30 is 35 neutrons. Okay? And if you take a look, I did this one on purpose because those are the same letters we did up here when we were talking about puppies and narwhals. And most of you probably didn't think it was too difficult at that point. So realize that whenever you're asking to figure out the number of neutrons, you take the atomic mass and subtract the atomic number to give you the number of neutrons. Another way of thinking about it is you take the number of protons and neutrons, subtract off the number of protons, and you get the number of neutrons. Don't be afraid of the words. Remember, this is the same thing. It's as easy as puppies and narwhals put together. All right, so let's just review what we're supposed to do here. To find neutrons, so to find the number of neutrons, all you're going to have to do is take the atomic mass number, which is the number of protons and neutrons together, and then from that you need to subtract the atomic number, which is simply just the number of protons, leaving you the number of neutrons. Okay, let's do some practice here. This is how you might see some of the problems. You'll be asked to figure out what the name is or the symbol and the protons, neutrons, and electrons. Let's start with the one that's pretty familiar to us here. It is 12, 6, and C. If we figure that out, you look it up on the periodic table. That is carbon. Whenever writing the name of an element, make sure to write it in lowercase. Because we talked about how elements can be a little heavier, a little bit lighter, it's customary to write which carbon you're talking about. In this case, it's carbon 12, since we saw that it had a mass number of 12 right there. To figure out the protons, neutrons, and electrons, let's see if we can decipher that. Remember from before that the lower left-hand corner there, that is the atomic number. The atomic number tells you the number of protons. So for this carbon, it would have 6 protons. To figure out the number of electrons, it's quite often that we have the number of protons is equal to the number of electrons if it's neutral. And if we take a look here in the upper right, there's no number listed, and whenever there's no number listed, we can assume that's 0, so the charge is 0, meaning that this carbon is neutral, and for our purposes, the number of protons is equal to the number of electrons. Alright, how do you figure out the number of neutrons? We talked about this before. You take the number of protons and neutrons, which is the mass number, subtract off the number of protons, and for our case here, 12 minus 6 is 6. So this carbon has 6 protons, 6 neutrons, and 6 electrons. Let's take a look at the next one. Be 10 and 2 plus. Let's start deciphering what we need to. Find Be on the periodic table. You will find out that it is beryllium. This beryllium happens to have a mass of 10, so let's go ahead and put that on the back. Alright, and now we got to start figuring out how we're going to do the rest. Last time all we had to do to figure out the number of protons was quite easy. We just looked in the lower left corner here, and we saw what it was. Notice it's not here, but it's okay, because we know that this is beryllium. And if you look on the periodic table, you'll see that all beryllium atoms have an atomic number of 4. So the number that should have been down there was a 4. And it's common that you'll see that not listed, because if it's beryllium, it's going to have a 4. So in this case, it has 4 protons. Now you might be tempted to write 4 electrons like we did last time. But remember I said that's only if it's a neutral atom. In this case, we happen to have an ion. So this beryllium has a charge of 2 plus. What that means is it's going to have 2 more positives, or 2 more protons than electrons. So for us, if we have 4 protons, and we're supposed to have 2 more protons than we do electrons, the only number that would make sense here is that we are missing 2. So we have 2 electrons. Let's go ahead and take a look how to figure out the number of neutrons, just like we did before. Take the mass number of 10, subtract off the atomic number of 4, and when you do that, you get the number 6. Clean this up a little bit. There you go. Alright, let's do it the other way here for chlorine 37. Look up on the periodic table, you'll see that chlorine has the symbol of Cl. We know this right here is telling us the mass, so that's 37. Also on the periodic table, chlorine has an atomic number of 17, and we'll just assume that it is a neutral atom. How do you get the number of protons, neutrons, and electrons? Chlorine, atomic number of 17. It's neutral, so it's going to have 17 electrons. And then to figure out the number of neutrons, like we've been doing all along, atomic mass, which is the protons and neutrons, minus just the number of protons. Can't do my math. 20. Alright, so that's how it works. Hopefully that helped out.